Alright, this is the last week, guys. We got exponential and logarithmic equations both combined. And this is normally something I would take separately, so kind of bear with me and try your best at these. Just a heads up, grades are updated as of Sunday, yesterday. So check those out, and you can kind of see what you need to get the grade you want moving forward. But we got exponential and logarithmic equations. We're going to spend most of our time with exponential equations, so let's get going with this. So there's a property that's called the property of equality for exponential equations. What basically all this says, if the base is the same, b of x, b to the x equals b to the y, then the exponents got to be the same if they're equal. So if the bases are the same, the exponents can be equal. So that's what we're looking at here. So an equation like this is actually pretty easy. The bases are the same. Both are base 5. So all you do is essentially just drop the base out. Just drop and just set the exponents equal to each other. 3x plus 4 equals 2x minus 8. Work on getting x by itself. So you subtract 4, subtract 2x, all that kind of stuff, and get x equals 4. And you're good to go. Alright, so that's easier ones. Another example here. Bases are the same. I just got 2 examples. They actually happen to both equal the same thing. Not that I meant to, but just did. Whatever. Next one. This is where the bases are not the same. But we can get them the same. 9 is the same thing as saying 3 squared. So what we do is we rewrite 9 in terms of 3 squared, and then we just kind of cross out the bases from there. So the bases drop out. I have a 2 that I need to distribute this time. So I go ahead and do that. I get 4x plus 10. You can do this as many steps as you need. I combine steps in here. I subtract 4x. I add 8. I get 3x equals 18, and then x equals 6. So I got that one for the third example here. Fourth one, just another one, just like number 3. I have 8 to the x minus 5 equals 2 to the 5x plus 7. So what we can do is rewrite 8 in terms of 2. So 8 is 2 cubed. Then you drop out the bases. I went ahead and distributed after that. And then I went on and got x by itself. And that's stuff that we know how to do already. Alright, so that's our first scenario. We have, I think it's 4 scenarios total in our equation. So that's the first scenario there. Second scenario is where I have a 3 to the x equals 17. We're going to start rounding here. We're going to need calculators for these ones. The other ones we don't really need calculators for, but right here we need calculators. So 3 to the x equals 17. 17 can't be written in terms of 3. So what we need to do is take the inverse of it. And exponentials and logarithmic equations or functions are inverses, as I mentioned very early on, a few weeks back. So what I do is I take the log of both sides. So you see here I take the log of both sides. Remember our properties. I can move the x out front. So what I do after that is I divide by the log. I do log of 17 divided by log of 3. So I type that in the calculator and go from there. I have a little calculator step here. So the calculator note, you do have to close the parentheses in the first log term, then divide by the second. So notice I didn't put parentheses on the second log term, and that's okay. But you absolutely need to close the first set of parentheses. Just keep that in mind. So that's my answer. I will be posting answers this week. It'll just come Monday or Tuesday, one of those 2 days. Give you another example here. Now, the first thing we need to do is we need to get what's being raised to the exponent by itself. So we need to get this 9 to the x plus 5 by itself first. So we subtract 3. Get 78 on that right side. Now take the log of both sides. Remember, move the exponent out front. Now notice here that a whole exponent is in parentheses. I still divide by the log term. So I'm dealing with a decimal from here. So log of 78 divided by log of 9 is roughly 1.983. Then I subtract 5 from it, and I get negative 3.017. Alright, so you're going to have to round to 3 decimal places like I'm asking. Now, a little side note. Something that's going to be beneficial to know for the next 2 problems. Natural log. Natural log of E is just 1. Alright, I mentioned natural log before, just in passing, mentioned it. Natural log of E is 1. So, in a problem like this, you have to get what's being raised to the exponent by itself first. So in this case, it's e to the x. So divide by 2 first. Get e to the x equals 9. Take the natural log of both sides. You can technically take the log of both sides, that's fine. But natural log is just better. So natural log of x, natural log of e to the x, you move the exponent out front, so x times ln of e. ln of e is 1, so x times 1 is just x. So x just equals the natural log of 9, whatever that is. In that case, it's 2.197. Alright, that's why natural log is easier to use. We don't need to divide by anything at this point. Another example here, this is our last exponential one. So same deal, we got to get the what's being raised to the exponent by itself. So e to the x plus 1. So subtract 5 first, that's it. Get 15. Natural log. Put the exponent out front. Give that a little side note again. So natural log of e is 1. So we have x plus 1 equals natural log of 15. Whatever the natural log of 15 is, 2.708. I subtract 1 from it. I get x equals 1.708. Alright, so we got that. Hopefully we're okay there with exponentials. Second half, shorter half, log equations. First thing I want to talk about, I'll just talk through one example. You guys can get the other one, no problem. I mentioned this property last week when we talked about the properties, but it didn't come to play with anything we talked about last week. This week it does. If we have log of x equals log of y, then x equals y. If the log is the same base on each side, then just whatever you're taking the log of equals each other, and that's it. So if I have log of 4x minus 7 equals log of x plus 1, the logs essentially drop out or cancel out. So we're left with 4x minus 7 equals x plus 11. And then all you do from there is get x by itself. So we got that. Same example, same type of example, it's just natural log. Both sides have a natural log, so they essentially cancel out. It doesn't matter if it's natural log, and then you just get x by itself from there. Alright, nothing too crazy. Last 2 examples. Now, we recall this property where we can rewrite it in terms or in exponential form. We go b to the x equals y. So here we don't have 2 log terms, so we need to rewrite it into exponential form. So it's b, so 2 to the 5th x equals y equals 4x plus 8. So we have this, 2 to the 5th equals 4x plus 8. Evaluate the exponent. 2 to the 5th is 32. And then you just work on getting x by itself. Subtract 8, divide by 4, x equals 6. First step's the hardest on all of these equations. Once you get past the first step, it's usually okay. Last example. Same exact type. I'm not going too deep into these equations that we should be spending much more time on this. So I just don't have the time, and that's okay. So we got 3 squared equals 2x plus 1. 3 squared is 9 equals 2x plus 1. Subtract 1. 8 equals 2x. Divide by 2. You get x equals 4. So we have that. That's all for our examples. There's a lot of examples. This is tough to figure out very quickly in about 10 minutes or so. This is something I spent a couple days on. So if you have questions throughout the week, hit me up. This is our last new assignment. This is our last new lesson. So you definitely have some extra time with it. So just keep that in mind. I'll be emailing people towards the end of the week about their grades and all that if need be. As always, if you guys have questions, talk to me. And if not, have a good week, guys. All right, this is it. Just wrap it up on a high note. See you guys.